Here are the answers for section 5-4. On page 168, we're asked to simplify this. As I look across the problem, I notice this piece has a negative exponent. Let's take care of that one first. So keep everything the same until you get to that last part. A negative exponent means a reciprocal. So we can write 3 over 2. And now it's to the positive one exponent, which you don't have to write down. We have a multiplication of fractions problem. The technique is to multiply all the numerators and multiply all the denominators. But let's reduce ahead of time to make the numbers smaller. 15 and 45 both divide by 5. 15 divides by 5, leaving 3. 45 divides by 5, leaving 9. Notice in the top there's a 3 and there's another 3. This 3 times this 3 is 9, and there's a 9 in the bottom. So using both of these 3's together is enough to cancel the 9, and that just leaves a 1. In the top we have negative 42, and in the bottom a 2. Those both divide by 2. So 42 divides by 2, leaving 21, and 2 divides by 2, just leaving 1. 21 and 28 will reduce. They both divide by 7. 21 divides by 7, leaving 3, and 28 divides by 7, leaving a 4. When all is said and done, there's a negative in the top and a 3 in the top, and in the bottom, a 4. Number 3, we have multiplication of fractions. Let's do the reducing ahead of time. 5 and 10 both divide by 5. 5 divides by 5, leaving 1, and 10 divides by 5, leaving 2. The x to the third on top and x to the third on bottom will cancel away totally. We're left with 12 times 2, which is 24. In number 5, there's a division problem. So let's first apply the rule about dividing, which is to rewrite the question, but change to timesing. Now that we have multiplication, we multiply the tops and multiply the bottoms. But before we do that, let's do some reducing. The numbers themselves don't appear to reduce, but the variables can reduce. A to the third on top, divide by a to the second. We can use both of these a's to cancel 2 of those away, creating a new exponent of 1. What we did was subtract the exponents. So final result is 15a on top and a 2 on the bottom. Number 7 is also division. So let's rewrite this as multiply. Keep the first fraction the same. Change to times. Take the reciprocal of the second fraction. Now let's reduce. 5 and 10 both divide by 5, leaving a 1 and a 2. The x minus 1 cancels the x minus 1. The final answer is 2. In number 9, we have a whole bunch of things being multiplied together, but some of them have negative exponents. Let's do the negative exponent first. So this first thing, we'll just leave it alone, 2a squared. But then this part here that has the negative exponent, let's take the reciprocal, 1 over 3b. This part here we'll leave the same. And then this part here on the end that has the negative exponent, let's do the reciprocal, 1 over 2a raised to the second power. As we look across here, this last piece still has an exponent on the outside of the parentheses. Let's do that next. So all this stuff at the beginning can stay the same. But when we get to this last piece, let's square the numerator and square the denominator. 1 squared is 1, and 2a squared makes 4a squared. Finally, we have removed the negative exponents and any exponents outside of the parentheses. Now we have a multiplication problem going all the way across, where some things are in the top, and then these two things are in the bottom. Before we multiply, let's look for any reducing. The 2 and the 4 will reduce. 2 divides by 2, leaving 1, and 2 divides into 4, leaving a 2. The 3 and the 15 will reduce. 3 divides into 3, leaving a 1, and into 15, leaving a 5. There's an a squared in the top, later on a squared in the bottom. Those cancel away. There's a b to the third power in the top, and there's a single b in the bottom. That single b will cancel away one of those, leaving a new exponent of 2. Looking across the top, we have a 1, then a 5, then a 1. So we have 5b squared in the top. Looking across the bottom, we have a 1, and then later timesing by a 2. So there's a 2 in the bottom. Number 11, before doing the multiply, let's take care of this negative exponent part. So we'll keep our first fraction the same as it was. And then the fraction that has the negative exponent, make its reciprocal. Now it has a positive 1 exponent, which you don't need to write. Let's look for any reducing. There's a 6 on top and a 2 on the bottom. Both of those divide by 2. So 6 divided by 2 leaves 3, and 2 divided by 2 leaves 1. We can reduce the 3 and the 15. They both divide by 3. 3 goes into 3 once, and into 15 5 times. Now let's try to reduce the letters. There's an A here, another A over there. In total, there are 2 A's in the top. And in the bottom, there's also an A squared. So if we use this one and this one, that's enough to cancel the A squared. What about the letter B? This B will cancel this B. What about the letter C? C squared in the top, but only a single C in the bottom. So this C will cancel one of these away, leaving a new exponent of 1. Looking across the top, we have a 1 times a 3. There's a 3 in the top. And there's a letter C that was not crossed out. Looking across the bottom, we have 5, and then later times 1. That's just a 5. Number 19. We have a division problem. The technique is to change to multiply and take the reciprocal of the second fraction. Let's do that. So keep the first fraction the same. Switch to multiply. Take the reciprocal of the second fraction. Before we actually multiply, let's see if there's any reducing. But these are binomials and trinomials. We cannot reduce those unless they're in factored form. So our next step is to factor every polynomial. Start with the 2z minus 8. We can factor out a GCF of 2. Next, do the z squared minus 4. That's a difference of squares. It factors as z plus 2 times z minus 2. Now in the other fraction, this trinomial factors using FOIL. So 2 sets of parentheses, z times z, and then what 2 numbers multiply to 8 and add to 6? How about positive 4 and positive 2? And finally, this last spot is already factored. It's just z minus 4. Let's look for any matching factors that we can cancel. Z minus 4 cancels this z minus 4. Z plus 2 cancels this z plus 2. I think that's everything. So final answer has a 2 in the top and a z plus 4 in the top. And in the bottom, there is a z minus 2. Number 23 is a very similar problem. The part that has the dividing, we need to change to times, and we need to do the reciprocal of that last fraction. So that's going to be our first step. Let's rewrite the whole thing and take care of that last piece. So we have 3a plus 6c over 9a times 12ac over a squared minus 4c squared times, and then let's flip this fraction upside down. It will become 2a minus 4c on top and 18a a cubed c cubed on the bottom. Before we actually multiply, let's do any reducing. But some of these are binomials, like this one over here, this one down here. We have to factor those before we can reduce them. So let's start with this right here. There's a GCF of 3, leaving a plus 2c. Down in the bottom, let's leave the 9a. Okay, right here, the 12ac is already written as a product of factors. But the a squared minus 4c squared is a difference of squares. It factors as a plus 2c times a minus 2c. Okay, now on the end, in the numerator, this binomial has a GCF. Both terms divide by 2, leaving a minus 2c. Down in the denominator, this is already a product of factors. Let's leave it alone. Okay, next up, let's look for some reducing. There's a 3 on top, a 9 on the bottom. Those reduce. 3 divides into 3 once, and into 9 3 times. There's a 3 on the bottom, there's a 12 on the top. They both divide by 3. 12 divided by 3 makes 4, and 3 divided by 3 makes 1. There's a 4 on top and 18 on the bottom. They both divide by 2. 4 divides by 2, leaving 2, and 18 divides by 2, leaving 9. I don't think that this 9 can reduce any farther with a 2 or with another 2. What about the letters? Does anything cancel away? There's an a plus 2c, which will cancel this a plus 2c. Hey, there's an a on the top, and there's an a on the bottom. Those cancel away. There's a c on top, and there's actually c to the third on the bottom. So this single c cancels one of those away, leaving a new exponent of 2. What about the a minus 2c? Can you cancel that? Yup, there's an a minus 2c down there. So that and that slash away. I think that's everything. So looking across the top, we have 1 times 2 times 2. That makes a 4. I don't see any letters left in the top. Now, down in the bottom, there's a 1 and later times 9. That's a 9. Are there any letters left in the bottom? There's an a cubed c squared. So final answer is 4 over 9 a cubed c squared. Number 13, we're doing review. But it's really the same topic we were just practicing, just a little bit easier problems. So we have a multiply problem, but before you multiply, take care of this piece that has the negative exponent. So let's keep the first part the same as it was, and then the part that has the negative exponent, put it down under the fraction bar. Now let's see if anything reduces. The top factors. Both 18 and 12 can be divided by 6. So we have 6 times 3 minus 2x. Down in the bottom, the 9 and the 6 both can divide by 3. So we have 3 times 3 minus 2x. The 3 minus 2x's cross away, and 6 divided by 3 reduces to a 2. Number 23 is very similar. This part here has a negative exponent, so we can move it into the bottom of a fraction. So keep the t squared plus t minus 6 where it is, but then put the other one in the denominator of a fraction. Now let's see if anything will reduce. But you have to have factored form. So let's factor that top trinomial using FOIL. T times t, and then we can use positive 3 times negative 2 as the way to get the negative 6. Now down in the bottom, let's factor this one. T times t. What two numbers multiply to negative 3 and they have to add up to positive 2? How about positive 3 times negative 1? Does anything reduce? The t plus 3's cross away. So final result, t minus 2 over t minus 1. Number 25, we already have it set up as a fraction. We just want to know, can this be reduced at all? Let's put this in factored form. The numerator is a difference of cubes. We know a way to factor that. Small set of parentheses, longer set. Take the cube root of the k cubed, keep the minus, take the cube root of the 1. Square the k, change to plus, multiply those together, you just get 1k, or just k, and then square the 1. Now down in the denominator, let's factor this. We can factor out a 2 out the front, leaving k squared plus k minus 2. Does this trinomial factor more? I think it does using FOIL. So keep the top the same as it was. And in the bottom, keep the 2, but then factor the trinomial using FOIL. K times k is the k squared. And to make negative 2, let's go with positive 2 times negative 1. Now we've created like factors. The k minus 1 crosses out the k minus 1. We can see that the final result is k squared plus k plus 1 on top. On the bottom, 2 times k plus 2. Page 164, this is where we were first learning to write division problems in fraction form. Fraction form is also called rational form as a ratio. So negative 8 divided by t is negative 8 over t. For number 6, the part with the negative exponent goes into the denominator. This becomes r minus 1 on top and r to the first power in the bottom. Question 14. Let's factor these and then see if they reduce. So the top has a GCF of 6, leaving y minus 3. In the bottom, this is a trinomial, and if it factors, it will be with FOIL. How about y plus 3 times y plus 1? Does anything cancel away? No, it doesn't. This is the final answer. Number 18. Again, we want to put this in factored form to see if anything cancels. The denominator is not in standard form. It doesn't have the right order. So the first step is to rewrite the order of the terms in the bottom. Put the negative w squared first, then put the plus 4. Because this has a leading coefficient of negative, we can factor out a negative sign and write it as negative times w squared minus 4. But w squared minus 4 is a difference of squares, so we can go farther. In the bottom, we have our negative sign, and then 2 sets of parentheses. W plus 2 times w minus 2. We did all that work to see if it would reduce, and now we can tell that the w plus 2 cancels the w plus 2, leaving a 1. Anything divided by itself makes the whole number 1. So final result looks like we have 1 on top, and on the bottom negative w minus 2. You can write it like this, or you can write it where the negative's kind of out at the very beginning of it all, and then 1 over w minus 2. These are the same thing. Page 160. This is when we were just practicing our 6 exponent rules. To multiply things that have the same base, keep the base, add the exponents. Number 4, to multiply things that have the same base, keep the base, add the exponents. This is just equal to x. Number 10, to multiply things that have the same base, keep the base, and add together the exponents. But when you add m and negative m, you get a 0. Any number to the 0 power makes 1. Number 12, to multiply things with the same base, keep the base, and add the exponents. But this just makes d to the negative 6. And when you have a negative exponent, take a reciprocal. Number 16, to divide, you subtract the exponents. So we have n to the negative 2 take away negative 6. And this makes n to the fourth. Number 26. To have a power being raised to another power, multiply the exponents. So this makes b to the negative 10. But because it's a negative exponent, do a reciprocal. Number 30. Same situation. We have a power raising to another power. Multiply the exponents. This makes y to the 0. Anything to the 0 power makes 1. The only exception is 0 to the 0 power is undefined. Number 36. What did we just say about 0 power? Anything except 0 to the 0 power makes a 1. Same thing here. It makes a 1. So final answer is 1 over 2. Number 40. We have a fraction. We're raising to a power. But the power is negative. So let's first take care of the negative exponent. It means to do a reciprocal. Flip that thing upside down. Now go to the positive 3 power. And this makes s to the 15th.